Welcome to today's video on Cambridge IGCSE Mathematics 0607 and 0580. The topic for today is geometry, where we will be looking at the subtopic angle theorems. We can classify angles into 6 different types based on their sizes. So when we have angles that are less than 90 degrees, so angles from between 0 to 90 degrees, we call them acute angles. Then we have angles that are exactly 90 degrees, and these are known as right angles. And when we have right angles, they are denoted by adding a small square between our angle to show that it's a right angle. Then we have angles that can be between 90 and 180 degrees, and these angles are called obtuse angles. Angles that are exactly 180 degrees are called straight angles. And if your angle is between 180 degrees and 360 degrees, then this is known as a reflex angle. Finally, we have angles that go the entire circle, or 360 degrees, and these are termed full rotation angles. Next, we're going to be looking at facts between angles that we can make on parallel lines. Now, parallel lines are lines that you can keep extending, and regardless of how much you extend these lines will never touch each other. And when we have parallel lines, we can denote that lines are parallel by drawing arrowheads on these lines. Sometimes you might see parallel lines denoted by just one arrowhead, and you can also sometimes see these denoted by more than one arrowhead. When you have parallel lines, you can connect these lines using other lines, and these can form different types of angles. The first angle that we're going to be looking at is our alternate angle. And when we form alternate angles, we are connecting two separate parallel lines with a line in between them. And this forms a Z shape. So this looks like the letter Z, and we can also see this sometimes being called as Z angles. And the relationship that we have between our alternate angles, that's the angles that we have within this Z, is that they're going to be exactly equal. So if my angle here was 60 degrees, then the angle over here would also be the same. It's also going to be 60 degrees. Similarly, if again we have two separate parallel lines that are connected by a line between them, then the angle that we find between these lines here within these parallel lines, so we can see that this is forming a C shape. We call these co-interior angles. And the relationship between our co-interior angles over here is that they're always going to add up to 180 degrees. So we said these are supplementary because they would add up to 180 degrees. If I say the angle in blue was 60 degrees, then the angle in blue and the angle in green have to add up to 180. So the angle in green should be 120 degrees. We can also have this relationship formed on the other side. So I can say this angle over here, along with this angle over here. Then these would also be co-interior angles, and they would also add up to 180 degrees. Finally, we have corresponding angles, and these angles are characterized by the F shape that we can make using them. So you can see that we're looking at the angle that's beneath the first parallel line and the angle that's beneath the second parallel line, and this is really important. And when we have these F angles, we're going to see, or something that we would be able to notice is that these angles would be equals to each other. So if I start off by saying that this angle in blue is 50 degrees, then this angle over here should also be the exact same. I can also extend these lines, and I can form a different set of corresponding angles by looking at the angles that are above my F in this case. So what I'm going to do is I'm going to look at this angle over here and this angle over here, and I can see that they're still forming this classic F shape that we can see. And this is the angle that's above my first parallel line. And this is the angle that's above my second parallel line. And these are going to be called corresponding angles. And because of it, these two would have the exact same value. We can say they are of the exact same magnitude. The next angle property that we're going to be looking at is vertically opposite angles. So this is when we have lines that are joining together or connecting at a specific point. Then the angles that are formed vertically opposite this point are going to be equals to each other. So over here, I can see two lines that are connecting at a point, and I have angle A and angle B that are vertically opposite each other. And the relationship between angle A and angle B is that they're going to be equal to each other. We can also form a second set of vertically opposite angles using the same diagram. That's the angle we have over here and here. You can see that they are vertically opposite each other, so they should also be the exact same. Now, additionally, something else that we can remember is because all of these angles are meeting at a point, so angle A, B, I'm going to label this angle C and angle D. So if I add up angle A, B, C, and D, then they all should add up to 360 degrees. So this is a relationship that we have between angles at a point as well as vertically opposite angles. Let's have a look at some questions involving different angle properties. So in this case, they've told us that the diagram below shows us line A, B, and CD, which are parallel to each other. And the first question is asking us to find the value of x and give a reason for our answer. Now, looking at the diagram, I can say that angle that they've marked 100, along with our angle x, these are co-interior angles. And I can see the classic C shape that they are forming over here. And the link that I have with co-interior angles is that they have to add up to 180 degrees. So I know that 100 plus x needs to give me 180 degrees. So x should be 80 degrees. So there we go. The value of x is 80 degrees. And they've asked us to give a reason for our answer. The reason that we are going to mention is because of co-interior angles. The second part of this question asks us to find the value of y, giving a reason for our answer. If I look at the diagram here, I can see y is here. And because I know the relationship between my parallel lines, I can say that this forms a Z shape here, which means that my angle y and my angle 100 are alternate angles. And the relationship that we have with alternate angles is that they're going to be equal. So because of that, I can say y should be 100 degrees. And the reason for this is because of alternate angles. Now, you might have noticed that there's not just one way to solve this, however. We can also solve angle questions in multiple ways. And I'm also going to show you another way we can get the answer for this. If I know that x is 80 degrees, I can see that x and y are lying on a straight line. For angles that lie on a straight line, we know that they have to add up to 180. So x plus y should always add up to 180 because they're on a straight line. We know that x is 80, so 80 and y should be 180, which gives us the answer for y. And y should be 100. So when dealing with angle questions, it's important to remember that there can be many ways to approach the question and still get the correct answer. So to quickly summarize the angle rules that we've learned here, so we've seen that when we have parallel lines, we can get alternate angles, we can get co-interior angles, and we can get corresponding angles. When we get alternate angles, we can see that alternate angles are going to be equal. Co-interior angles, on the other hand, are going to add up to 180. And finally, corresponding angles are also going to be equal. Then we've also looked at the fact that vertically opposite angles are going to be equal. And that's it we have for today's video. Thank you.